Um, Engineer Kunde is our facilitator for today. Some of us may already know him. To
Good morning, everybody. We are all welcome for this to this section. Now, we all had the topic designing reliable lithium battery inverter system. It is important to have a system that is reliable. Very, very important. So to save a lot of, in fact, a lot of things, you make more customers, you have rest of mind, you are confident of what you do, and many, many more reasons why your system must be reliable. Why reliability matters? Let's look at it from this angle. Failures are expensive. Lithium battery inverter system requires substantial upfront investment. It's not cheap at all. When reliability is poor, failures often affect multiple components, leading to costly repairs, replacements, and service visits. We need to now to consume time, give a lot of headache. So it's matter. It matters to really make sure that our system are reliable. Mitigating risks. System failure leads to costly downtime, significant safety hazards, and accelerated degradation of battery life, impacting operations. You can see how they are interconnected. When batteries are bad, then when the system is not reliable, is shutting down frequently, or is overloaded, or cable size, it will even lead to some components getting on flames. So because we've seen a lot, so it's destructive. It's one cannot even afford it, and anybody who wants to succeed, who wants to remain relevant in the industry, must have a reliable system. Now, customer trust and brand reputation is one of the reasons why reliability matters. Customers expect system to operate reliably with minimal intervention. They don't even want to go and touch it. If it's possible, wherever they are, they just call or they just tap their phone. Life must be easy. So that's what they want because they paid for it. So they want to enjoy that. That's why you see a lot of customers want any little malfunction on this, they shout, they talk, because they have other parts of life to attend to. Cannot afford, I paid for something and then I'm not getting the advantages, and rather it will be giving me headache in addition to other things I need to attend to in life. So it's important. It's really important. Repeated failures quickly erode customers' confidence and can damage a brand reputation. That's just it. It's clear. So typical lithium battery inverters system. We have PV array, talking about the solar panels. If it's a complete solar system, then you have solar panels connected to it. And all this must be well sized, go through manuals, follow instructions from the manufacturers who design all these things. They also don't want the system to fail. And they don't want you coming back or returning it or changing brands. You want to go because it's not working well. Definitely, you move to another brand that is reliable. So follow instructions that they have given in the manual. and then you get a good result. Then inverter itself has to be sized well, because the capacity of the inverter, there's a lot in the inverter. If you want to use lithium ion, your inverter must be compatible with the lithium ion batteries. So it's important, so that there will be communication, proper management, and all. Charger controller, maybe using external charger controller, depending on the system design. Then you have the lithium batteries themselves. There are various capacities, various sizes, forms. Some are wall mounted, some are standing alone, some are on rollers. So various, you choose the one that you want, provided you are getting them from a reliable source. And then it will make the one that, of course, you discuss with your client. Your client may be telling you that, oh, I want wall mounting. During your survey, you will have seen all this. You can also advise. Battery management system, which is the BMS, which has to do with the battery itself. It's also part of this inverter system. The inverter should be able to interpret the instruction from the battery and use it, present it to you on the screen. You see it, and then when it's ready to give commands back to the battery, it should be able to do it. But for an inverter that is not communicating, the BMS is useless. Protective devices like breakers, SPDs, which are other components of the system installed, just to make sure that the solution is quality. Now, best practices for designing reliable lithium batteries inverter systems. The first one is design for continuous load, peak load, and contingency. You know, because during survey, when you measure your load, you already know before you deploy an inverter system or the battery a certain capacity of battery, you will know what the load capacity is, how they want to use it. So all this matters. Consider the expected backup time. Then you can discuss this with your client. Your client will tell you that I just want it to just as a stopgap between when generator will start and then when this, or I want to use it in the afternoon for my children. I want to use it to power AC in the night. All these conditions are part of what you must consider when deploying a reliable source, a reliable solution. So design for maximum 80 to 90% DOD. Of course, this is a good battery, which you cannot get from the all those lead acid batteries. So there is a lot in this. The battery has its own advantages, which makes it far better than the wet cell, the AGM, and other types of batteries. So proper cable sizing and layout. Apart from making your installation look neat, if you don't use the standard gauge of cable at different parts of the design, and there is a loss of power, then your system will not be reliable. Because if you are supposed to use 35 mm and you are using 6 mm, they are not the same. They can't carry the same maximum capacity of current. So it's important to size properly, lay them out well to make it neat. This will eliminate temperature rising, shutting down when the battery is not low, and then the inverter will be seeing it that is low, and overworking that's stressing the BMS, because all the cables must be proper standard. Appropriate AC/DC protections, like all those surge protectors, where you need to use DC circuit breakers, where you need to use AC surge protectors, you put them appropriate values. Make sure they are in positions, where they will do the work properly. And then the correct ratings of these things matters. Surge and lightning protections are also very essential. I put very essential because you are dealing with lithium-ion battery. They have communication ports. They can pick interference around. If your system is not well screened, is not well filtered, it is not well heated, the battery can pick noise through the inverter and then it will start misbehaving. It can shut down, it can do this, it can be displaying a battery capacity that is not the real. Anything can happen. It is better to just get it right at once so that you don't start be concerned about is it the cable? You now have a lot part of the system to think about that. Is it this? Is it this? Is it because they didn't tighten this well? Is it because I used this gate? Is it so? If you have done everything well and it's proper, then you get a very good, excellent result. Environmental consideration. You don't install your system where there is drainage, where there is water, or where there is high temperature in the kitchen, where there is the fumes of oil, and all this you consider. They need to save, they need to be cool, they need to be off all this moisture. Don't say because they say this battery now maybe is labeled IP64, then you put it where there is water or rain is falling on it, or the inverter is you put it. No. So we need to be conscious of all this. Then I will say it again, let us follow instructions from the manufacturer. Battery and inverter placement, like I said, you look at the position where you want to put them so that it's convenient for your customer to even be able to see what is going on the inverter. Because if you go and put your inverter just on top of wardrobe or under decking, and then your customer needs to see what's going on the screen, it's difficult. That's why you see most of all these inverters, they rated them, they designed them that you put them and you install them at eye level. Your customer should just be able to stand in front of it and tell you, oh, this is what I'm seeing. If it's the one that is online, okay, you can go through your phone to see the performance. The same thing is applicable to battery. There are some batteries you mounted on the floor. There are some on rollers, some on the wall, some on the rack. Some you put them, they have the racks within themselves. So you don't need an additional rack. So you just put them one on top of the other and you couple them, they form racks and then they stay neatly. You will know which is suitable. You are in position to advise your client better. So grounding and earthing, I mentioned it before, very, very important. But you don't need to ground terminals of solar. Don't ground terminals of solar cable. It's dangerous to the batteries and the inverters in the solution. Then the BMS communication and monitoring. This is very important. If this is established, then you will enjoy full capacity of your battery, full performance. That's when you can drain the battery because you are not the one to determine where the batteries will be shut down. You can use it like 95% determined by the management, which is the BMS. It is the BMS that will be able to monitor the temperature and give alarm. Oh, this environment is rising in temperature, is this. It is the BMS that will be able to say, okay, inverter, this is the current you should give when charging. The battery can decide to take 100% charging current. It's not your problem. So as long as there's a proper communication between the inverter and the battery, then you can open your inverter at a time. You scroll through the settings, you see that, oh, it's just taking 5 amps. Meanwhile, the proper communication is established, it's not your own to do. It's the battery management and that is doing that. The battery knows when it's going to request for 100 amps. It knows when to request for 2 amps. So because of the design of the battery itself, they designed the battery management such that it will be able to manage the battery properly. Now, lithium battery inverter communication. What is being communicated? You'll be wondering, well, what are they even communicating? Are they speaking Yoruba or English or Igbo? It's not like that. These are in codes. And then they communicate the battery status, state of charge, SOC. You know, is the battery fully charged? You can see what the percentage of the battery is on the inverter if proper communication is established. The same thing, not when battery is telling you that I am 10%, and the inverter will be telling you that the battery is 200%. You'll not be wondering, why am I seeing these low bars on this? No. If proper communication is established, it is whatever you are seeing on the screen of the lithium batteries that you also see on the inverter in terms of SOC percentage and all. You know, there are some lithium batteries, they only have LEDs, they don't have liquid crystal display that you can see and read something, but yet they are lithium ion batteries. Some lithium ion batteries don't even have communication ports where you put BMS, but they have their limitation. Technology is getting advanced day by day. Charge, talking about what they even communicate. Then charge and discharge current limits, like I mentioned. So it will tell the inverter, oh, give me this. I need 20 amps now. The inverter will push it 20 amps, provided it's available. If the solar is there to deliver that energy, and there's a request from the battery, the BMS will make it possible, so that is achievable. The battery voltage and temperature, yeah. When it's rising in temperature, maybe the environment is a little bit hot. Of course, we are not supposed to put your battery in a place where it's going to be hot. But for instance, maybe the battery has been in operation and it senses a rise in temperature. The BMS will control many parts of the system. Oh, temperature is rising. Okay, charging, reduce. Until when the temperature is reduced so that I can fire on with the batteries. So all that is not your business. But you just make sure that you have done your due diligence. You have put the battery in a normal place. When the temperature rises based on operation or anything, the BMS and the function of the battery knows exactly what to do. They will just adjust themselves. So common protocol. Now we have a false alarms and protection signal. These are what are communicated. You can send to the inverter that, oh, I'm too low. Please charge me. And it will give a warning code on the inverter. If maybe some people will say, well, what's this?
I know.
Continue to be using it on. It will finally shut down, because if you don't have energy to sustain the system, to sustain your load through this communication and everything in the battery and through the power in the battery, is exhausted and it's telling you that I need to be charged and there's no source of energy to charge the battery, it will finally shut down. And shutting down is a way to protect the life of the battery. So then common protocol, we have CAN and RS 485. Those are the two common protocols. That's your communication cable coming from the battery, from the inverter, is either entering the one labeled CAN or is entering the one labeled RS 485. But this is communicated to the installer in the manual. It will have been stated somewhere in both batteries manual and the inverter manual. You will see. So you don't just take decision that I want to connect it here. No, you must go through it and know where to connect it. Now, operating without communication, risk and mitigation. It has its own risk. Over discharge and overcharge risk. because there's possibility when you are operating without communication, and then your inverter is capable of firing the battery, it can get overcharged. When you are loading it, you can get over discharge. But what do you do? That's where the mitigation strategies comes in. If I mentioned that there are some batteries that they don't even have communication ports, yet they are lithium-ion batteries and they are in use. It's just that they have their limitation. Now, what do you now do if you happen to find yourself to connect to batteries that do not have communication, or the inverter is not really supporting fully? Maybe it doesn't have communication ports for lithium-ion battery, but to be economical, and then probably before the clients will agree to change it to a modern type that can do that. But you can still manage it, you can still use it. It's not that it's not going to work. The only thing that will just happen is that the range of operation on the battery will be narrowed down. That's when you properly adjust or program the inverter, which is the mitigation strategies that we're talking about. Conservative voltage setting. You would have to set the voltage on the inverter that, okay, please, inverter, as you are draining the battery when my client is using it, when you get to so value that I'm going to set now, please stop. Give alarm at so point that the battery is low, then stop finally. So that value we are going to set now will be the low battery cutoff point, but it's going to be a little bit higher. Generally, it's about 48 volts. If you don't do that, by the time the battery goes below that and goes down maybe to 42, because it's not communicating, it won't wake up. When you now have sources to charge the battery, it won't wake up. In fact, the battery will protect itself by disconnecting from the inverter. So the inverter will no longer recognize it that there is battery. You see, to avoid all this wahala, you now to strategically set the voltage that high, so that when it cuts off at that about 48 volts, you still have some energy, you still have a certain voltage level. Then when power now comes to continue the operation, the battery is still live, so it will be able to connect and start to charge. Then higher battery cutoff point, cutoff voltage. So you have to set, which is what we just mentioned now. That's the higher battery cutoff voltage. Then reduce charge and discharge current. Then you can do that by putting some inverters, you can set the maximum load on it. So this is also applicable to like a general situation for all the batteries. If you know that the current of the battery cannot withstand the load, then you have to strategically put things in place. Is that you set on the inverter, if the inverter has that function that, oh, you must not be able to load it beyond this power, then when you want to do that, the inverter will tell you overload and probably shut down. Or you put external devices that you have set to help you do that. So when you put them, you set them, oh, this device, you must not allow the client to load it beyond 1000 watts. When the client tries to do that, it will cut it off. It's already in your agreement. So you have rest of mind. And then nothing will happen to the battery. It will always be doing its function. It's just that the backup time will be shorter than when the BMS is fully in control. So that's that. Common lithium battery inverter system error. Inverter undersizing or poor surge handling. Battery undersizing, improper cable sizing. These are the errors that most installer do on site. They will undersize the inverter. The inverter will not be able to supply the required charging current. It will now stay there over a long period, and they are using it. So, or they want to power the whole building because they say the battery is 10 kilowatt hour. They remove the hour in front and assume that it is 10 kilowatts. Yes, I can power 10 kilowatts with 10 kilowatt. 10 kilowatt hour battery is just about 1,000 watt load. But because of the strength that the battery has, you can now load it. It has the current which you can put in place. Okay. If they say it's 10 kilowatt hour, battery is a time component. Works with time. If you load it, as you increase the load, the time the duration is going to stay powering your load will reduce. So that's why the hour is there. So if you now overload it beyond its rating, it's going to shut down. That's part of the protection that is inside the battery. Then you now see it's shutting down, it's showing alarm. When you have allowed surge that is bigger than the battery to ride on it, it will just be showing alarm and be shutting down anyhow. So the battery undersizing is still part of what we are saying. You size the battery, maybe your clients need 10 hours backup time. You now size battery that will not be able to do that. They will now be complaining, they will be calling you and the battery is shutting down, is this, that. No. You are stressing the battery. Forget about all these protections that are there. It's not that they are not working, but you are giving it a lot of stress. So then another one is improper sizing of cable. Many people are fond of if it is 10 kilowatts and just let me use 16 cable. It will charge now. What's the charging current that is? By the time this battery demands for charging current and is saying I need 100 amps, and the inverter is capable of giving it that 100 amps, and you are using a tiny cable, it's going to be eating up. It won't see it. So a lot of calculation will be going on through the BMS. So trying to manage the battery current, trying to do everything, the cable will be eating up. When you want to load it, the same thing will be happening. Because when you load it and then you are not getting, you are loading it and there's a drop along the battery cable, then the battery will still be full when your inverter will be telling you that the battery is low. And then eventually there is an error. Because battery is saying that my capacity is high, and the inverter is saying no, the battery is low. So communicating, it will now be showing funny errors. Just do what is proper. That's why you have standard sizes for all these things. Cable has standard current that capability, insulation breakdown value. Then a lot. So make sure you follow all these details while dealing with these solar systems, lithium-ion batteries. Incorrect polarity, battery will just shut down. You can even damage the battery. You understand? It's not proper to allow incorrect polarity on inverter. You can damage the inverter itself. Because when you connect positive to where negative is, and then you want to fire the inverter on, or you connect solar, you reverse it, or which is not proper. A lot of things will happen. Missing or inappropriate breaker size. Two things will happen when you inappropriately size breaker. Is either the capacity of the breaker is higher, then allowing higher current to flow when it's supposed to shut down, when it's supposed to trip off. Then what are you protecting? For instance, you have an inverter now that you're supposed to protect with 20 amps. You go and put 100 amps or 150 amps. Then it's as if you are not protecting anything. So you are stressing the inverter up. The inverter will now be the one doing the protection by itself. It's not that some of these inverters don't have, but they have. But when they now fail, if you don't have double protections there and there, you just within a short time, you just discover that something has happened. Then you start going up and down, transport, distraction here and there. Poor ventilation. If you keep them in a hot environment, they'll be complaining. Both inverter and the battery can complain. I can tell you. And then if they complain and nothing is done to cool them, they shut down. So please, it's important to follow all this. Now we have SVC, Life PO4 batteries. So you can see in the pictures, we have different models. At the left side, we have SVC 12 volts, 230 amp hour block batteries. It's a lithium-ion battery. It's also intelligent, but does not have communication ports, but it's still within the range of operation of AGM battery, and it has capacity than AGM. You can't compare it. It's still all those advantages that you talk about in lithium-ion battery is there. You can monitor it with your phone. It has Bluetooth, so you can see the charging current is taking. You can set your inverter to deliver so charging current, and it's 230 amp hour is real. So it's light in weight, small in size compared to AGM. You can carry it with one hand compared to a 200 amp hour battery that's very heavy. And then, there's a lot of advantages in it for people who maybe they prefer it for certain reasons, maybe to back up some system or they want to use it, they want to replace their batteries, they are using AGM, they now feel that, oh, I still want to use batteries like that. These are batteries that are okay. You can connect them in series. You can still connect 4 in series. You can still make series parallel if you want. They work perfectly. Now, you can see the one at the middle, SVC 5.12 kilowatt hour, 100 amp hour, wall/rack mounted. So when it's rack mounted, it doesn't mean that you need to go and buy an additional rack. No, it's having that rack as part of its body. Just put them one on top of the other one. You can as well turn the back and mount it on the wall, depending on how the environment is. So it's flexible. And then it's having the liquid crystal display. It supports all the communication. It has the BMS, the battery is there and everything. So all these batteries have Bluetooth. They have some of them have Wi-Fi connection. So you can see the one by the right, which is SVC 5.12 kilowatt hour, 5.6 volts, 200 amp hour. You can see the difference between the two. The first one, the one at the middle, is 100 amp hour, while this is 200 amp hour. It's rack mounted, basically rack mounted for this one. While the one at the middle, you can put it on rack chain. So we have the next one, which is SVC 8 kilowatt hour, 25.6 volts, 314 amp hour, floor mounted. This one is on roller. You can see the terminals on top, which makes it easier for you to connect to battery. It reduces the length of cable and makes accessibility very easy. You can see the cover, you cover the terminal, prevent the terminal from dust, and makes it is a protective guard too for maybe children around. They can't just get access easily directly to the terminal, So, and it's portable, rolls around, and the rollers have lock under them. It's also Wi-Fi connected, it's Bluetooth connected, so it's flexible. So you connect to your inverter, and then you can change your protocol directly from the screen. And it's also touch screen, just like your Android phone. So all these features are available in the battery. Then you have the next one, which is SVC 10.5 kilowatt hour, 51.2 volts, 205 amp hour. Then it's wall or floor mounted. You can see the way it's standing on the floor. Then it has bracket that you can also mount it on. It's looking very portable, very neat. You can see the way your cable will have the top you are seeing now is a cover that also protects against dust. And the cover is open at the back where your cables can just flow out, So nobody sees the terminal directly. And when you mount it on the wall, it's neat and very smart on the wall. It also has all these features. You can connect to internet, you can monitor them, you can use Bluetooth around when you are there. Bluetooth is only for when you are close by. You can see what's going on your phone with Bluetooth. when you are, but when you are away from there, it's only the internet that will make you see what's going on inside them. So you can see the one by the right side, which is SVC 16 kilowatt hour, 51.2 volts, 314 amp hour. It's floor mounted. That is a bit bigger than the one we just described, and it's also intelligent. It's having double terminal that you can connect without sharing. If you just need two inverters to connect to it, or you want to loop to the next battery, it's easier. You don't need to create a kind of bus bar because you want to link to the other battery for now. But if you want to connect a lot of these batteries together, you need a bus bar to make everything seamless, uniform, and standard. So now let's see SVC all-in-one system. All-in-one, as the name implies. That means it's like a standalone system. It's having the batteries connected directly. That for some, you don't even need cable. For some, you just need a link. For this one here now, you just need a short link that is provided from the manufacturer. So you don't need external battery cable or external battery breaker. Is there. So all you need to do is bring your solar cable, bring your input grid, and then your load cable into it, and then you are good to go. Very easy to install, very fast. Make life much easier. It's not more your headache whether the inverter is going to communicate or not, because they are the same family. They already know how they communicate with themselves. So you won't get yourself bothered. And then there won't be any discrepancy, or the battery is Pylon Tech, or the battery is SVC, or no. They are the same family. They just communicate seamlessly. If there's any error, they know they communicate seamlessly. So, but you can decide to say, okay, I want the top with just one battery. The topmost part of all this all-in-one is where the inverter is the inverter, while the lower part of it is the battery. You can see SVC RPS 1.2 kilowatt / 4 kilowatt hour, a solar generator. As it is, you have the inverter, that's the flat one on top, while the battery is the one down. That's all. Just connect your cables to it, connect your solar cables, connect everything, and you are good to go. You don't need to use screw to start mounting a lot of things on the wall, because it's looking neat. You can decide that, okay, maybe the client decide that they want to relocate it. It's very easy. You just those cables that you connect to them, you just transfer them to the new location, and you carry this, you go and put it there, mount them there. Very easy. Then in a short time, you are done. So if the client wants to say, okay, I don't have money now for 2 batteries or this, you can buy one and start with it. Later, when you have the money, you buy the second battery, you put it on it. The same inverter still manages them. So the same thing applicable to the next one. You can see that one is having 2 batteries, and each battery has its own display here. On this one, each battery has its own liquid crystal display to be telling you what's going on. And then the inverter, naturally communicates with the battery. That one too, you can decide to use one battery, you can decide to use 2 batteries, even up to 3 or more. So that's that is SVC RPS 1.2 kilowatts / 1.28 kilowatt hour battery. Now, the SVC RPS 3.6 kilowatt / 8 kilowatt hour all-in-one, that's the one by the right. That's a little bit bigger. You can see it's on roller. Each battery for that one is 5 kilowatt hour, and the inverter is 5. For this one now, this is 3.6 kilowatt. We have them in various capacities like that. So, but this one is 3.6 kilowatts, and the battery is 8 kilowatt hour. Now, still talking about the SVC all-in-one system, you can see the one by the left side, SVC RPS 5 kilowatt. The inverter is 5 kilowatts. On this picture now, the battery is 10 kilowatt hour. That is, each battery is 5 kilowatt hour. You stack them together. In stacking them together, you don't need to be peeling cable, log, and it's just the same way I explained. Just put them one on top of the other. You put the couplings, and that's all. So the one at the middle is 6 kilowatt hour. You can also use 10 kilowatt hour battery. And the topmost part is usually the inverter, the hybrid system. Now you have SVC RPS 11 kilowatt. The inverter is 11 kilowatt. So it depends on the capacity you want. You can see them in various capacities. You can see the bracket by the side. You see two brackets by the side on this one I just mentioned. That's the one you use to hold it to the wall. Just put screws, to hold it to the wall so that it doesn't move around. That's all. So it stays, because it can be taller than that, and then risk of falling. That's why it's provided with that, so that you couple it to the wall and it stands by itself. Then here is conclusion. Reliability is designed, not added later. I think this statement is clear. Design it from the beginning. As you are making your design, you should design it to be reliable. So that because reliability is when it's now working and they can feel they can enjoy the advantage, do everything, and it's there working on its own, not giving you headache based on the design you put there. Not when you just put things, you just put one cable, you just put anything, and then they are calling you, you are now upgrading, you are now doing that, doing this, changing cables. That is not reliability. In fact, you are going to lose that client if you do it this way. Because you won't even have rest of mind to run after other businesses that will fetch you a bigger money. So please, small design decisions have long-term impact. So please take note of this. No matter how small the design is. I mean, small design decision, yes, have a long-time impact. A decision you make now, it can be there for life. You can even make the customer not to have interest in whatever solution or any other time, because the customers they are all human beings like us. The way you reason is the way they are family. So when you are poisoning their mind from the beginning, then it's not easy to convince them that I can now do it better. What did you do from the beginning that you didn't do better? And now you want to. Some of them have taken their decision that I don't even want to use this inverter again. I've heard in some years back, somebody said, inverter is a scam. I cannot use inverter, because the installers that he has come across, this one will just put this one in place. He spent a lot of money, he's giving headache. Another one will say, no, the one that did rubbish. Oh no, because they didn't connect the solar panel like this. No, you need to change the battery. This battery. So all that. That's just, if this is the way I will enjoy my life with this solution, I don't even want. By the time he becomes angry and removes the system, he won't be interested in anything again. I said, no, let me have rest of mind. I want to live long. It's not these things that will kill me. You understand that kind of a thing. So it's important to design a reliable system. I wish us best.
All right, thank you so much, Engineer Kinde, for that enriching session. I trust that we've learned so much. There are also a number of questions that we would have. There are already some in the chat box, so I'll just take them. You can also drop your questions in the chat box, or if you have a question, please raise your hand, and we'll call on you to ask your questions. All right. So the first question here is we shouldn't ground or earth the solar cable when it gets to the SPD surge. I think Engineer Kinde spoke about that when he was talking about designing reliable systems, some of the things to take into consideration. So please kindly take that question, sir.
Okay, when I mentioned that you should not ground solar cable, it's clearly stated in the inverter manual. The solar cable that I'm talking about is not the SPD itself. It is the solar cable coming from the roof, and you now tie one of the terminal. You know, you for your solar cables now you have plus and minus, red and black. You now connect one, maybe negative. You now connect your earth cable directly to it. It is dangerous to the inverter. So hybrid system, hybrid solution. It will just be, it can kill the charge controller inside the inverter. So it's always stated that you should not do that. So, but for the SPD, is a short protective device. You are required to connect their earth terminal to earth cable, and your earthing must be functioning, must be active, not just earth that's there, that is not when you now carry out earth test, it's failed already. Or some people will just take cable that is floating. When you run a floating cable to a system and you use it to represent earthing, it will carry cable, it will carry voltage along, interference, and you now introducing interference to your system. So let it be definite, it's well defined. This cable is earth cable and it's going to the ground. So that is it.
Thank you. Okay, sir. Thank you so much for your response. Please let's mute our mics to avoid disruptions. So the next question here is please share more details on how to properly size cable and breakers. This is going to be it's more of a lecture or training, special training. Our advice that you join our upcoming training, Solar Academy, coming up next month. The date will be communicated. Like I mentioned, you can register on our website. But you can just shed in a few minutes more light on that question on how to properly size cable and breaker.
Okay, thank you. In brief, if you want to size, for instance, the input cable for an inverter now, you need to have an idea of what's the maximum current that will flow. So when you know the maximum current that will flow, you don't want that maximum current to now be the one that will overheat your cable. So your cable must be able to withstand. So there are standard data that will tell you, okay, if the current that will flow is 20 amps, you go and check the cables. You can check online for some. Then you will see for 20 amps, this is the size of cable that you can use. So you follow that. But by standard, there are measurements, Then for breakers too, the same thing. If you want to protect a device, your breaker size, the size of breaker now is referring to the current rating of that breaker, should be smaller than the maximum capacity of that device. For instance, your inverter is 5 kilowatt, and then the maximum current that's supposed to flow at the output should not exceed maybe 22 amps. You want to protect that inverter. You are not putting 32 amps. 32 amps will not trip. Your inverter is already experiencing overload. So you look for what is slightly smaller than the maximum that is to protect your inverter. But if you want to use the output to protect other things, that's is a wide this thing that requires a lot of explanation. But in simple, that this as I mentioned now, that's the simple way to size them. Then they have ratings on their body. Some protectors, they have ratings. You follow that. You go through the manual another way. They would have indicated in the manual that use so size of cable. You understand? You can, but some people say it's too expensive. Why will I want to install 5 kVA and go and use a 35 mm cable for the battery? If you calculate it, you look at what's the maximum current that will flow through this cable. and you now go through this process that we said now, that you go and check if the current is maybe 200 amps. Okay, what is the size of cable that can withstand 200 amps? That's the cable you should go for. So that's it in a nutshell.
Okay, thank you so much, sir. So next question, yes. For the 12 volts 230 ampere SVC like PO4 battery for a non-hybrid system, is it safe to select AGM as battery type on the inverter, and for hybrid user or AGM? Question is not so clear, but I think Jacqueline can pick some things to answer on that.
Okay, when you want to use, when your battery and your inverter are not communicating and you want to use a hybrid inverter like that, because we mentioned that you should safely, strategically set the parameters so that you don't run into trouble. Now, if you choose AGM as stated in the inverter, AGM is like a protocol on its own. You may not be able to change some values like bulk charging voltage, because once you click that AGM as the setting, it will fix all that value for you. So, and all these values, they vary from battery to battery. The value that is going to put there for you may be different from what you want to put. So it is better to use user define. That means you want to determine the values you want to put for bulk charging voltage, float charging voltage, low battery cutoff. Because if you press that AGM now, it's going to set the low battery cutoff point for you, and you won't be able to adjust it. And we are saying you should set 48, so you won't be able to set 48 again. So it is better choose user defined, whereby you'll be able to individually set all those parameters yourself. Then you are good to go.
Okay, thank you so much, sir. So I see Mr. Lukman Oladiji's hand is raised. You can unmute and ask your question.
All right, thank you very much for the lecture. I just have a few questions, just two questions. The number one question is there any negative effect of BMS on inverter? That's the number one. And the number two question is, I will actually put a short scenario. In a situation whereby an installation whereby they still use NEPA. So when there is NEPA, the NEPA supply the load directly, but there are some appliances that the NEPA lights does not work with, so they have to use stabilizer. So I want to know the effect of that stabilizer at the output of the inverter. So that's just the two questions. Thank you very much.
Okay, thank you for your question. The first question is negative effect of BMS. Technology keep getting advanced every day. It can always get better. I cannot say this is the negative effect of BMS, because the BMS is an intelligent electronic part of the battery that will be doing the work instead of you going to monitor temperature. When you are using AGM batteries, you need external temperature monitor to couple to your battery, if you want to install a standard system, you need that. You couple them to the body of the battery so that it will reduce charging when some charge controller come with it. Some you have to tie it to the terminal, some you stick it to the body. All these are done inside the battery, which is an advantage. Then external battery balancers that we use on like other batteries, the AGM, they are incorporated in the BMS to make sure that each cell is balanced in the battery. So I don't think there will be any lithium-ion battery without BMS in them. So whether you now want to link the BMS inside the battery with your inverter to communicate and make all this seamless communication and make life easier to enjoy the full capacity of the battery, that depends on you or the type of inverter you are now using. But I can't say these are the disadvantages, because there is a lot more advantages. So now, on the scenario painted that what's even that?
Using
Saluko, please, could you take your second question?
scenario whereby they are using NEPA, they are still using NEPA with their inverter. So whenever NEPA is available, the NEPA supply the load directly.
Okay.
So, but the NEPA current is not enough to power up some appliances like their freezer, so they have to use stabilizer. So now the stabilizer is at the output of the inverter. So I just want to know if there's any effect of that stabilizer, because if there's NEPA,
okay,
they
I
are
got you
using
right.
the stabilizer. Okay, if there's, that was just it, sir.
Okay, yeah. This depends on two things, but naturally, it's not proper to be having stabilizers at the output of inverter. Now, this is one of the reasons why it's not proper. Stabilizer, because of the way they work, when there is low voltage, they try to boost it up. They take very high current to do that. So they are causing additional load to your system, to the inverter. Some inverters, when you are doing that, you put for the same load, you can put this in practice. Just do calculation. Okay, if you have 230 volts and it's 5 amps that is flowing, 230 times 5 is going to give you a value. That same value now divide it by 100, assuming that is 100 volts that is passing. You see that the current will change from that 5 amps to very high current. That's the same way that is happening in the stabilizer. So it's going to draw more current through this thing, and it can lead to overload. If you are having protective devices that you're okay, they should not overload it, it will trip. And if you don't have it, it's overloading the inverter itself. So it's going to waste energy from the battery when the battery now finally comes to play. So you are waiting. When the battery now comes to place, you will not go and remove the stabilizer that is already at the output. So you will leave it there, especially for all these small inverters. But if it's a very big inverter that has that problem, they have that problem in their location, and you want to do that, maybe you want to now protect some small loads with stabilizer. Big inverter may not see it as anything. Talking about maybe 100 kVA inverter now, and then when grid now comes, it's low, and then you are now looking at it. It's not that because for you to stabilize the inputs of that stabilizer, of that inverter now that is big, you require a very big stabilizer, so which is going to be very expensive. You don't want to go through that route, and the loads you are talking about, maybe they are just smaller part of the load. It can stay at the output because it's a smaller load for a very big capacity of system. But for all these small inverters that we install at home, all these domestic DC, it is not advisable to put stabilizer at the output of inverter. It wastes energy, it contributes switching, noise, and everything. So it is better you put stabilizer at the input. Get a stabilizer that can do that. If it's 5 kVA, you can use 10 kilowatt, 10 kVA stabilizer at the input. That ensures that the inverter will work normally, will see normal voltage to operate with and all. So when it's now doing on the battery, it's not wasting energy into anything, it's just powering the load straight away. I think that answers your question.
All right, thank you so much for that answer. So we have Mr. Adeyemi, but please let me take a question from the chat before we take your question, Mr. Adeyemi. So we have a question here from Mr. Kinemi. Can all-in-one series be parallel to increase capacity? I think I'll just take that question. So like we mentioned, we have different capacities of the all-in-one system. So if you see my screen here, so you would see the 1.2 and 1.28. So for this particular capacity, you can actually parallel the battery, that's increase the batteries up to 4 units. For the solar generator, I also saw a question related to that. So maybe I answer that at once. You can increase the capacity of the battery. So it's just the 1.2 and 4 kilowatt hour. Yes. So for the only one, you have a 1 kilowatt. Sorry, that's an error. It's a 1 kilowatt inverter and 1.28 kilowatt hour battery. So yeah, you can increase the battery capacity. Okay. So for the RPS 5 kilowatt, 10 kilowatts are all in one system. So you can increase the battery capacity up to 3 units. So that's 15 kilowatt hour. For the 6 kilowatt, 10 kilowatt hour, it can be scaled. So you just have this unit to work with. But for the 11 kilowatt and 16 kilowatt hour, it can be expanded. The inverter and the system, because it comes as a unit. So you can expand that system capacity and even connect it to an external battery. So you can get more details about this product on our website, www.genextechnologies.com. Mr. Jeremy, please, you can take your question now.
Okay, good morning, Mr. Engineer Akunle. Thank you very much for that wonderful teaching. Really appreciated it. My question is just simple. I just want to ask that is it advisable to grant a lithium battery? And why am I saying this? There was a case whereby, not my installation though, but there was a case whereby um, the transformer of that area got blown up, and they could discover that the transformer itself wasn't properly heated. So why the current was trying to find its pathway down to the earth beneath, so it got connected to some of those earthings in the building, and there's this lithium battery that was grounded. So in that situation, the battery was badly affected. So it damaged the battery, the BMS, and every other thing. So because where I'm talking of, I also installed a system very close to that place. So my own system, it was just the SPD that was badly affected because I didn't ground my battery. So, but the other building very close to mine, that's his battery was grounded, everything. So it damages both the inverter, the battery, and every other things. So that's why I'm asking this question. That is it always advisable to ground a battery? Is it always advisable? That's for one. That's question one. And the second question regards to you know, earthing of, the output of a panel. Some connect to the SPD, and from the SPD connected their earth, and some connected to the already existing earth in the building. And why some do connect directly the ground directly through the frames of the panel, which is most preferable? Thank you very much.
Great. This last question now, just before you go, please say it again, because there's one part of it that I did not hear clearly.
Okay, the last question was that you talk about, how to help the solar panel. You talk about connecting to the SPD, then connecting to the existing earth in the building. Why some connect ground the solar panel directly without even connecting to the SPD. So I'm just asking that which is most preferable, because I've seen a case whereby a solar grounded directly without connected to the SPD caught fire. So that's why I'm asking which of this is most preferable in terms of, trying to protect the panel from unwanted currents.
Okay, I got you. Okay, the first one, now that's a battery grounding, whether it's always appropriate or proper to ground batteries. Well, grounding is the way to to protect ourselves and protect the appliances. If there is a leakage to the body of that appliance from inside and is grounded, then it will protect you because you are on the ground. Is either a circuit breaker trips, you are tracing, at least to indicate something is wrong somewhere that has to be corrected. But for all these batteries, for lithium-ion batteries, some of them are provided with terminals where you can connect cables to ground. But many people don't do that. Because once your inverter, which is the most important one to be grounded, to be connected to earth, is most of them are iron body, and then AC is not going into the battery. It is the DC that is going in and out, although it's connected to the inverter. But then it is important you ground the body of the battery, of the inverter, not the battery. Now, for this scenario you mentioned, well, if it's not connected, because if you connect your communication cable, which could be a source of link of noise, if there is noise, if the inverter is not properly grounded and there is noise transfer, it will go through the communication cable. But if your inverter is properly grounded and everything is okay, you don't need that. It's only in the place where you now see maybe there is clear that there's a problem and you have to do that and it's provided on the body, then you can go ahead and do it. The manufacturer says do it this way. But many people don't do it, but it's not so important for batteries that way. All these small batteries. But when it becomes industrial, you have to. In fact, you won't commission the battery if you don't ground it. So I think I need to be clear at this. For all these domestic things, you play around with them there, yes, because the only time they can misbehave is when there is a small interference and all that. But for industrial battery, you have to provide earthing, a special earthing for them. If you don't do, you should not commission. So that's what I'm going to say on that. For inverter, it is standard. Make sure you provide your earthing and test. All those earthing has to be tested and confirmed okay. It's not just connecting it that is important. The earthing themselves must be standard. They must be active. You can't load earthing now and then you are now reading between neutral and earth. You are seeing 50 volts or you are seeing 200 volts and you say the earthing is okay. You now connect to the body of you connect to the earth terminal. No. When you load your earthing, if the earthing is proper, you should see 0 point something, 1. That is it. So that's that. But for the earthing of solar that you mentioned, talking about SPD base, your surge arrestor, your surge, what's it called? Lightning arrestor has nothing to do inside where you put your inverter. Your lightning arrestor has nothing to do with your connection with your inverter installation inside where you connect the inverter. Because when there's the lightning flash, it's thousands of voltage, and you wouldn't want that to escape into the inverter system. So that's why it's going straight to the ground. When it flashes, it is the function of the element up there to attract it and send it through a standard cable. If you are doing that and you are now using 2.5 mm to connect lightning arrestor, you have not connected anything. Because that flash, just before it gets to the ground and notice that and drag down, there will be a huge drop which can see damage electronics. So that's why you see in some places like in some installation like all this telecom system, you see that they are using 35 mm cable for earthing. So some of them they use 70 mm to do that, and they don't joke with it. So if your cable is not standard enough, you have not done anything. So that's that. So your lightning arrestor is just taking this. Your lightning arrestor can also be connected to the frame of your solar panel up, but not to the terminal of the solar panel. It has nothing to do with the terminal of the solar panel. You know, the rails, they are coupled to the roof where your lightning arrestor is coupled. Automatically, they are connected together. The rails are there. All of those ones are connected together. It should just go straight to the head, to the ground. So when your solar cables now come into the building, it's going into the breaker and it's going to the SPD, then you can now take the earth part of the SPD to ground, which the ground where it's going to is not the same point of you are making different connection. The ground for lightning arrestor is different from ground for earthing. So it is your earthing which is connected to the body of the inverter and is connected to the appliances in the house that is connected to your SPD earth point. That is the way it should be done. I think that answers that question.
Thank you very much for this. So now, among these two processes now, which is most preferable in trying to ground the solar panel?
Trying to ground your solar panel is only the frame that can be connected to the ground or connected to with the lightning arrestor to the ground separately. Grounding in your solar system are two. Your solar cable going into the building goes into the circuit breakers, goes into the surge protector, and your surge protector earth point, earth terminal will be connected to the earth of the inverter, which is the earth of the building. So those are the two connections. I think it's clear.
Okay, thank you very much.
You're welcome, sir.
All right, thank you so much, Engineer Kundi, for that explanation. So I'll take a question from the comments before we go to Mr. Kolawole. We have a question from Mr. Abubakar. So two questions. Can we scale up all-in-one inverter? I think we've already responded on that, and you can always get more details on our website. The second question is comment. I think we should state the wire sizing in your manuals, which should guide every installer and a client. Including breakers. Including breakers. This will help installers and clients who want quality. Okay, so the cable sizing, recommended cable sizing and breakers are always in our product manuals. So if you go through the inverter manuals for any of our products, you always find them there. So please always do well to check them. We even also share them, those details across, WhatsApp platforms. So once you engage with any of our sales personnel, they would always make that information available to you. So we also extract them from the manual for easy access and share across commonly on WhatsApp and other platforms. So those informations are always available. Number 3 is also there are some of your SPC batteries refusing to communicate with some of your Gen X inverter. Example is 10 kilowatts, 100 amps. That should be 10 kilowatts, 100 amps. This should be a peculiar case because we have all our inverters, batteries. They communicate well with our Gen X inverters. So if there's an issue with the system you have, please kindly share that details with us, specifically with us what the issue is. So we look at that closely and find a resolution to that. So there's another question here I would like to take, which I think Nyakunle has spoken to. Please, on the grounding of solar cables from the roof, does it mean we should not add the solar panels chassis and ground it? Nyakunle already spoke a bit to that. I don't even want to expand on that a bit also.
The solar panel chassis is the same thing as your lightning arrestor. Your solar panel chassis should not go into the building and connect to the building's edge. It should go through a separate cable to a separate point on heads. It should have its own rod or something separately. It should not be connected to the earthing of the house. Because when this lightning flashes, the rack too can pick it up. It's just as the lightning arrestor will pick it up from there. And once that happens, it should take it, the cable should take it down to earth separately. It should not be taken into the building. The one that is connected to the SPD is the earthing of the building, which is a separate thing. Earthing that's connected into the DB, that's connected to the inverter, to that. Or in some cases, some people will even abandon that one. They'll go and do separate earthing for the inverter solution. So that's the one. If you do separate earthing for inverter solution, that separate earthing now is the one you will connect to the inverter, connect to the SPD, not to the roof, not to the chassis of the solar panel.
Hi, Mr. Kolawole, please unmute and ask your question, sir.
Hello, good morning.
Good morning,
Hello?
sir.
Yes, please. My question is, how do we protect inverters when using?
Hello? Hello?
Okay, since we lost Mr. Kolawole, probably a network issue. So pending when he's back, we'll take another question on the platform. At what load size do you switch from low voltage battery system to high voltage battery system? At what load size do you switch from low voltage battery systems, and we were talking about the 12 volts, 24, 48 volts low voltage battery system, to high voltage battery systems, which are in the range of 100, 500 and above?
Yeah, I think in most cases, this part of the decision is taken by the manufacturer, because you can have 2 kilowatts inverter with 12 volts battery, while you have some 2 kilowatts, they are using 4 batteries, 48 volts. So high voltage battery system could mean like 300 and something volts or 600 volts. There are batteries like that, about 600 volts for battery. So some of them are lithium ion, so they have their BMS, they have everything. They are not, you are not the one to determine whether I want to connect this one to this one. No, everything, the arrangement has been made by the manufacturer. Like, this is a module, so you connect them this way, and this is for those high voltage inverters. You cannot get access to the terminal of the battery. It's not for you to be connecting cables, and no. Some of them can be standalone like this. Just put them one on top, and yet they are high voltage batteries. So it depends on the inverter you want to get. The manufacturer already made that decision. If it's power that, okay, 10 kilowatts, you can get a 10 kilowatt system that is still 48 volts battery. You can get 15 kilowatts. You can even get about 20 kilowatt system that is 48 volts. So it now depends. If you want to be doing like 100 kilowatts, yes, as a single unit, you may not get those ones at 48 volts, because 100 kilowatts, the current that will flow at that time is very high. So at that point, they want the current to be reduced. That's why they increase the voltage. The power is still remaining the same. So the manufacturer already know. I think they are in best position to decide on that. But for you as an installer or a client, you want to say, okay, probably because of money, I don't want to use 4 batteries. I want to be doing it small. If you want to use 4 batteries and you want to start from 1 battery, that means you want to be using 12 volt battery. And that inverter must be capable of being able to deliver power into 4 at the end of the day. You can have a 2 kilowatt system that is 12 volts. So you buy 12 volts battery today, tomorrow, maybe, okay, you buy another 12 volts, if it's a little bit high voltage, you must put all the 4 batteries together at once. So that's where the advantage of the low voltage is. You can cascade, you can wait, you can, so that's it. I think that answers your question.
Thank you, sir, for that response. We have a question from Mr. Prince Goodness. Please, what is battery grounding, and how can a battery be grounded? I think this question came in when you were speaking. We're responding to Mr. Demi's question were related to grounding battery.
Grounding battery is only applicable to batteries that the body are made of iron and the manufacturer has already put on the body, labeled it Earth. You see the logo there that this is Earth. That Earth meaning that you should connect it to ground. Not grounding the terminal. Please, nobody should connect terminal either positive or negative to Earth. It's going to damage the inverter. Most of all this hybrid system, they will just get damaged or they start showing funny behavior. So they don't do, as you are not expected to connect solar cable, either plus or minus to Earth. You are not expected to connect battery cable, positive or negative to ground. But for those appliances that are made of iron on their body, and they say you should connect to ground, then that is what we explained that time. So many people don't do it because some of them don't, because they are you can easily interact with them, and the inverter that is connected to them is also grounded. So they just take that, okay, inverters are grounded, so let's leave this. But if it is big industrial battery, the position on the body, the iron, because definitely industrial batteries are made of iron, the body is there. You have to connect your Earth to the body. It is compulsory. Thank you.
Thank you so much for that clarification, sir. So, Mr. Colloway, please take your question now if you can hear me.
Yes, I can hear you now. Yeah, my question is this: how do we protect a hybrid inverter from surge, grid, or generator? Because I've seen some situation where the generator and NEPA is being connected to hybrid inverter to charge the battery. So how do we protect the inverters? Can we still use normal SPD breakers we normally use, or we should go for AVR? That's my question.
Yes, it's a good thing to protect when you have different sources coming into the solution. But then, the best solution is to make sure that you have all recommended protective devices available with normal and standard rating. That is the very best thing. Then, your SPD is there, which you have to put in place as AC input surge protector. They will have to be there. Then you now have the circuit breakers, which they have their own way of protecting. It's only when excessive current flows, that's when they will strip off. We have different categories of surge. There are some that are like steady over a longer period. There are some that are transient, that are very fast, and they are high voltage. Your SPD will attack those that are very high in speed and the voltage is also high. You will notice when they come. It could be flash from welding machine around or anything that rides on the cable. The SPD that you have connected at the input will trap it down and your system is good to go. So those ones will be there. It doesn't now mean that because you have SPD connected, you cannot use voltage regulator, you cannot use voltage switcher, which is a power monitor. No, you still need all those things as a matter of standard. If it requires putting stabilizer, if you have a lot of fluctuations, maybe it's going up and down or is actually low, just like somebody mentioned at that time, you need stabilizer at the input. Put the stabilizer there. And when the stabilizer is there, you still now need, as a matter of standard, all this power monitor. If it's a single phase system, at least you need a single phase power monitor that monitors voltage. In case the voltage just steadily go up and stays there for over some time, that thing will just cut it off. It's not that your inverter has been designed not to accommodate high voltage, but why will high voltage come into your inverter? Because it can accommodate it. The inverter will now switch it to the output and spoil appliances. So it's better you cut it off from the input. You set it. Anybody that is going beyond 240, 245, 255 is abnormal. You let the voltage monitor strip them off until when it's normal or within the normal range. And then why it is important to have power monitor at the output of your stabilizer is stabilizers themselves, they switch here and there, they can go slightly above a certain DC, they can create a kind of surge that you don't know. If it's the relay type now, they will step up from a so all that times you need something in case the voltage now goes up. Then what cuts it off? The power monitor is there to trip it off. Stabilizer, when it's damaged, can supply 300 volts. And then when it supplies 300 volts, are we saying you should just go straight into the inverter system? Your power monitor is there to shut it down. When you now see, oh, this is what is happening, the stabilizer is bad, it's now supplying. That is, the stabilizer doesn't mean that it cannot go bad. I've seen a lot. At times, some of them will now create a kind of window in the course of their function. That window is either shut down, and then when you now trip on to connect again, you now see high voltage, or that window is high voltage before it comes down to. So all that, anything once it's faulty, anything can happen. But you now want protective devices. So your stabilizer is a protector, your power monitor is a protector. If it's a 3-phase system, you still need a phase sequence.
A ní issue pẹ̀lú ilẹ̀kùn 104 ni. Ilẹ̀kùn sáré táṣì ẹ̀ replace ni. So mo ti wá pé your boy ẹ̀.
Make sure that when it is reversed and then all your system you don't switch neutral, especially for 3-phase system. It is very important. Don't be switching neutral, because if you do and it's open at one end and you supply 3-phase at random, you can just get different voltages. All appliances in the house will be going back. So let by standard all your neutrals be coupled to a bar. It's very important.
All right, thank you so much. So we'll be wrapping up the session soon. So just take 1 or 2 questions before we wrap up. So we have a question from Mr. Olushiri in the chat. Said, please, there is need for further clarification on the earthing in an inverter system. It seems there's a lot of question around earthing. So we have DC SPD and AC SPD, that's surge protective devices in the system. Are we to connect these 2 devices to the same earthing parts in the building, or create a separate earthing parts for the DC SPD? So the AC and DC SPD, are they supposed to be connected to the same part in the building, or there should be a separate earthing part for the DC SPD?
Okay, thank you. Now, earth is earth in the building at your inverter stand. Earth is one. It's as if you have earth bar, and any part of your installation there that requires to be connected to earth, you connect cable to it, you take it and connect to that earth bar. So if the body of the inverter is to be connected to the earth, you take it to the bar. If the SPD, because the DC SPD, you take it to the bar, to the same bar for earth, which is the same earthing of the building, which is different from surge, lightning arrestor. So earth at your inverter stand is the earth of the building, or unless you are doing a separate earthing. And that earth now is the singular earthing where the earthing terminal of all your SPD, inverter, everything around that, your installation will be terminated to. As a matter of standard, that's the way it is.
Thank you so much, sir. So the very last question, which is actually a repeated question, Mr. Osade mentioned he didn't hear you when he had bad network. We're answering the question about load size for low voltage battery systems and high voltage battery systems. So the question was, at what load size do you switch from low voltage battery system to high voltage battery system? So, Mr. Tan, you can just drop a comment in the chat to be sure to confirm that you can hear us. So, Mr. Janakule will take this question now.
Okay, like I mentioned, I said the inverter manufacturers already are in position to take that decision. Because if you are buying a brand or a model of inverter or a capacity, they have already designed the battery type is going to use. It's just for you to now provide it with the battery capacity that is required, battery voltage. If you are buying a 12 volts inverter now, it's already stated it is 12 volts. If you are buying a 48 volts, the battery voltage is 48. But we now have where some industrial, even some domestic, this that are all in one. They are high voltage systems. Some of them are lithium-ion battery, lithium-ion batteries incorporated that are about 500 to 600 volts battery voltage. Those ones you won't have access to the terminals of the battery. They are hidden. They are highly protected. So it is some of the inverter could be just 15 kilowatts that they design like that. So you'll be using it. But it's the manufacturer that determines what that to be. But for your own determination, maybe you want to use a low voltage, maybe 12 volts or 48 volts. It depends on the pulse or how you are going about the design. If somebody says, okay, I want to use two battery, 12 volts, and my load is not more than 500 watts, you'll be talking about maybe 12 volts. So if it's 12 volts and he wants to use two batteries and he's telling you that I don't have money now, like this lithium-ion battery that we were talking about, you want to buy one and you are still going to buy two or you want to buy three. So that means you must use a 12 volt system. Because you can't be dealing with 48 volt system and you want to be using one battery that is 12 volts. So that's where your own determination comes in. So if it must be 48 volts, by standard, the manufacturer has already designed. So just to keep the system with the voltage level or the capacity of battery requested or required by the manufacturer for the battery, for the inverter. So that's it. It's not at a point you can get, but when it is industrial, like 100 kilowatts, 100 kilowatt system are not 12 volts battery. They are not 48 volts battery. If you see 100 kilowatt inverter, they are in most cases high voltage. It could be 300 and something volts or 400 or thereabouts. But it's designed, the manufacturer know the battery that they would have put it there that this is what you should do. So if you want to use external batteries, they are designed them that they should work with other batteries, good. But these days, they work with lithium ion and they are customized, C and I. So that's it. I think I've answered that question.
Okay, I see Mr. Osade's hand is up. Do you want to ask a further question? That's the last question we'll be taking.
Yeah, thank you very much. Thank you very much, Mr. Conley. I just wanted to explain the scenario. So at the site, the load is 24 kilowatts. So with my calculations, I'll need an inverter of 30 kVA. So a direct 30 kVA inverter is three phases high voltage. But I also wanted to do grid support and normally for for three phase high volt, which is high voltage, if there's low current, the inverter will not charge. So I'll not be able to do grid support. So I was now thinking of splitting the load into 15 kVA inverters, 2 units. So I only use on two phase and leave one phase because still the 30 kVA is not supposed to carry the whole house and the battery is 100 kilowatt hours. So that's why I'm now trying to I'm trying to ask because in a low voltage situation, if they are really using the load, the current pool is going to be very high rather than the current pool from a high voltage situation. So that's the actual scenario I'm in, and that's why I'm asking because for lithium battery. So that's why I was asking the question. That's what I was really trying to know that is it still safe for a load of 24 kVA to use a low voltage approach with 100 kilowatt hours of battery if I'm going to do use only two-phase, or I should just do the three-phase and do high voltage? So that's what I was asking.
Well, it's I think maybe we'll see talk more after this on this design you mentioned. But then we have systems that, like in some stations now, we connected all this parallel. 10 kilowatts will come in 48 volts, and you parallel them, and they are three phase. 15 kilowatts will come in 48 volts, and then, but if, because it's not you that will just determine that you want to change, increase to high voltage, and then you want to use lithium ion battery. You cannot just say, okay, I want to parallel, I want to connect this 48 volts lithium ion battery, I want to connect two of it in series. No, because the BMS function is very important. It's not unless if the manufacturer of such battery has indicated that, oh, my battery you can connect in series. If not, it's not applicable. It's not advisable. So if you are dealing with a high voltage battery system and you want to do some adjustment, I think I need to understand it more better. Maybe after this class, I will understand better, maybe through pictorial diagrams or anything. Then we'll find a way around it, and then we'll get the solution. But right now, you cannot determine to use these lithium ion batteries. For each of them, they have their BMS, which is working. So you can parallel. And even in the parallel connections, they've stated that you can connect so numbers to still make them all communicate together. So if you want to do a transition to high voltage because of low voltage supply from the, it has to be well looked into. It's a design that one needs to look critically into to really know, work with the inverter that you have, see whether it's going to work or not. Because at times the inverter, you may have an inverter and then it's not suitable. It's either you just follow what it can do, or you abandon it, get another one that can do the new things you want it to do. So we'll look at that more closely after the. So let's get them going.
Okay, sir. So thank you so much. I think we'll be wrapping up the session right now. So I want to thank everyone for joining in and for the questions. Those questions were actually eye-opening for most of us. So thank you all for joining, for engaging. This session was being recorded, and we'll have it available on our YouTube channel, Genesis Technologies on YouTube, within 48 hours. So you can always go back to watch and share with others. So you can always reach out to us via our different channels. To have the shop, genextechnologies.com. You can go there, look for any of our products, and actually it's an e-commerce platform. So make your purchase online. You can get more details about Genesis Technologies on our website, and also our products, www.genextechnologies.com. And you can also reach out to us on phone and WhatsApp with the number displayed on the screen. And like I mentioned earlier, it's a continuous learning process. So we have a Solar Academy, Genex Solar Academy coming up soon, batch 17 in March. So we employ you to join in, and also, get others to join in as well. So you can register on our website so that you would receive information once the actual registration for the academy is ongoing. So thank you once again for joining us. We look forward to having you again next month on another webinar session. Thank you and have a great day.
Yeah, thank you. Yeah, bye.
Okay, thank you. Thank you very much.